Yeah, good afternoon, everyone. Welcome to class once again. My name is Adeyemi Adekunle. So I want to continue with our class on calculus, and I could remember I stopped at chain rule for us last class. So today we'll be proceeding with product rule. So I'm going to be giving us the scope under product rule and how to go about some questions regarding that. All right. So if you are talking about product rule, it has the format y equals UV, and our dy dx is equals to u dv dx plus v plus v du dx. So this is the format for that. But instead of going through all these steps, we can just use a scope method by saying you differentiate the first one, then you keep the second one, plus you differentiate the second one, you keep the first one. When I say keep, I mean you rewrite. So for instance, if you have questions like y equals e raised to power x, ln x. Don't forget I told that ln x is the same thing as log x bc. This can also be written as, well, you can write it as y equals e raised to power x log x base e, which is the same thing because ln x is the same thing as log x bc. So differentiating this one now, this will be your u, y this will be your v. I mean, ln x will be your v, y e raised to power x will be your u. But instead of going through the stress of using this particular formula, you can just scope it by saying differentiate the first one. That is, you differentiate e raised by x. And if you remember in my first class, I talked about derivative of e raised by x. The derivative of e raised by x is still e raised by x. So differentiate the first one, which is also e raised by x. Keep the second one. When I say you keep the second one, I mean you write the second one. So writing the second one means ln x. Then plus, you keep the first one. When I say keep the first one, it means you write the first one, which is e raised by x, and differentiate the second one. The second one is ln x. So if you should differentiate ln x, don't forget it will be 1 over x. So we have it as 1 over x. Meaning my dy dx can be e raised by x ln x plus e raised by x times 1 is e raised by x over x. You can leave it like this, or you factorize. Since e raised by x is common, so we can have e raised by x into ln x plus 1 over x. So this is an example on how to go about product rule. So I want to solve another examples, maybe just 3 examples or 5 examples for us on this, so that we'll be able to get it very well. All right. So always remember, differentiate the first one, keep the second one. When I say you should keep, I mean you should rewrite. Plus, keep the first one, differentiate the second one. Another question says, if y equals 2x plus 3 raised to power 4, and we also have 3x squared minus 2 raised to power 10, raised to power 10. So this is the first one, right? Which is our u, and this is the second one, which is our v. So using the scope, our dy over dx will now be differentiate the first one. The first one is 2x plus 3 raised to power 4. Don't forget I gave us a scope regarding this. I say if you want to write this, if you want to differentiate something like this, you can use chain rule. But instead of using chain rule, you can just scope it. And how do we do that? So differentiate what you have in the bracket. Differentiate 2x plus 3, that's 2. So 2 into bracket of the power, you times with the power, which is 4. Then into bracket of, you write the main question, 2x plus 3, then raised to power, we remove 1 from the power, which is 3. You can go back to my previous video to look at how to solve questions on chain rule. All right, so we have, for the first one, derivative of the first one is 2 into 4, then open bracket, 2x plus 3 raised to power 3. Then keep the second one means you rewrite, that's 3x squared minus 2, then raised to power 10. Then plus, now, we write the first one, which is 2x plus 3 raised to power 4. That's keep the first one. Differentiate the second one. How do we differentiate this? This also can be solved using chain rule. But instead of that, we can scope it. And what is the scope? Differentiate what you have in the bracket. If you differentiate 3x squared minus 2, that should be 6x, right? Because 2 is a constant. That will be 0. Derivative of the constant is 0. Now, differentiating 3x squared should give 6x, right? Then we times it with the power. And the power that we have here is 10. Just like the way I did this. We times with the power Then you write the main question. Writing the main question is 3x squared minus 2. Then remove 1 from the power. That would be 9. So we have it as 8 into bracket of 2x plus 3 raised to power 3. The other bracket of 3x squared minus 2 raised to power 10. Then plus, we can just multiply this one first. 2x times 10, that will be 60x. Sorry, 6x times 10, that will be 60x. So we have 60x into bracket of, so we have 60x into bracket of 2x plus 3 raised to power 4. Then 3x squared minus 2 raised to power 9. All right, so well, you can stop here, and if you like, you can still proceed with it by factorizing. You can proceed with it by factorizing. What I mean by that is from here now, we can do something. Looking at this very well, we can see that 8 and 60x, there is a factor common to them, which is 4. So bringing out the 4 first, 4 into, then this and this, there is another factor common to them. 2x plus 3 raised to power 3 is common. Then 3x squared minus 2 raised to power 9 also is common. So we are now left with, for this now, this has gone. So 4 in 8 is 2. We have 2 left. Then 2x plus 3, 2x plus 3 has gone. Then we'll be left with 3x squared minus 2 raised to power, that's raised to power 1. So we can just leave it that way. Then plus 4 in 60 is 15. So we have 15x into, we notice that 3x squared minus 2 raised to power 9 has been factorized out. So we'll be left with 2x plus 3, right? Because we have 2x raised to power 3 coming out, and we have 2x plus 3 raised to power 3 coming out, and we have 2x plus 3 raised to power 4 here. So we'll be left with just one of it. So that's 15x into 2x plus 3. So you can just stop there. Well, depending on the if it is OBJ questions, it depends on the options that you have. For instance, you might see your option this way, you might see your option this way, and you might also see your option this way. You will get it. So you just have to be very careful with your final answer, depending on what the option is showing out. All right, so moving on to the next questions. Moving on to the next question on product rule. Moving on to the next question on product rule. Sorry. All right. So the step is very, very easy. You just have to be combining some of the things that we've done in the previous video. You just have to be combining them together in order to have a perfect solution. Another one says if you have something like y equals s squared cos into bracket of let's say into bracket of 2s squared minus 3. How do we solve this? This is the first one, u, right? Y, this will be the second one, v. So our dy dx for this one, you know I told you that they can also write it as y prime, right? Instead of saying dy dx, you can write it as y prime. So following the scope, differentiate the first one. Differentiating the first one means you differentiate this x squared, and that will be what? 2x. You rewrite the second one. This is the second one, our v. So let's rewrite it. That will be cos into 2x squared minus 3. All right, so plus, keep the first one. That will be x squared. When I say you keep the first one, it means you write the first one. Now, differentiate the second one. How do we differentiate this? We can differentiate this by the idea of chain rule. So I will or just to go and watch my last video on our chain rule. How can we differentiate this? The first thing that you have to do is you differentiate what you have in the brackets, meaning that 2x squared minus 3, differentiating it, that will be 4x, right? Then into differentiate cos itself, that will be minus sign. Then you write your main question, which is 2x squared minus 3. Good. So we can have this as 2x cos 2x squared minus 3. Then we notice that this minus will affect this plus, so we change it to minus. Then x squared times 4x, that will be 4x cubed sine 2x squared minus 3. All right, so looking at this again, something is common. 2x is common. So we can be left with cos 2x squared minus 3, then minus 2x squared, right? Then sine 2x squared minus 3. So that's what we have on this. So it's very, very easy. Y equals s squared cos 2x squared minus 3. Our dy dx of y prime or derivative is going to be 2x into bracket of cos 2x squared minus 3 minus 2x squared sine into bracket 2x squared minus 3. Then we close the bracket. So it's very, very easy. And you have to be very careful with the bracket because some options might be tempting. You can see options like 2x cos 2x squared minus 3 minus. You should definitely know that. You should definitely know that that will be the answer. Why? Because bracket is not coming in. So you have to be very, very careful of the position of the bracket in each of the write-up. So, all right. So moving on to the next one. Moving on to the next one. Moving on to the next one. We are still on product rule, and the format that we are using for product rule is that you differentiate the first one, then you rewrite the second one, plus you rewrite the first one and you differentiate the second one. Differentiate the second one. All right, so let's check questions like which will be my last question on product rule. Y equals let's say we have y equals sine 2x tan 2x. What was y? Y equals sine 2x tan 2x. How do we differentiate this? It's very easy. Our dy dx also will be equals to differentiate the first one, differentiate this. That will be, don't forget the scope. You have to differentiate what you have in this bracket, which is 2. Then differentiate your sign, which is cos. Then 2x. We've differentiated sine 2x like that. Then rewrite the second one. That will be tan 2x. Our second one is tan 2x. Then plus, keep the first one. Now we have to keep this one. And that will be sine 2x, right? Into differentiate the second one. You have to differentiate what you have inside there, which is 2, right? Now differentiate tan. That's sec squared. Don't forget your standard derivative. That's sec squared. So that will be sec squared 2x. So in general, I can write it as 2 cos 2x tan 2x plus 2 sine 2x times sec squared 2x. So that's all we have for that. All right, so moving on to the next one. Actually, there is a way of scoping questions related to quotient rule, but it's kind of logical. You have to be very, very sound at solving indices and sodical terms. All right, so let me just do one example related to this. Quotient rule always deals with division. Actually, it's always deals with division. Like if you are saying y equals let's say y equals cos x over sine x, or you are saying y equals tan x over e raised to power x. So the one that deals with division is always quotient rule. It's always quotient rule. So what does quotient rule say? Quotient tells us that if you have y equals u over v, that your dy dx will be v du dx minus u dv dx over v squared. So let me just give us time to write that. If y equals u over v, u is the numerator, v is the denominator, that your dy dx or your y prime is going to be v du dx minus u dv dx, then over what? V squared. Please always remember this. It is over v squared, not u squared. All right, so let's look at a very simple example on this. For instance, if you have y equals, let's say you have 2x minus 1, then 3x plus 2. This should be your u, right? This should be your u. So from here, if u now equals 2x minus 1, then our du dx means we differentiate it. Differentiate 2x minus 1, that will be 2. Differentiate 2x, 2. Differentiate the constant 0. I've told us that already. Then if v equals 3x plus 2, my dv over dx will be equals to what's there? That's 3. Now, following the formula, dy dx, which is v du dx minus u dv dx over v squared. So we can say that our dy over dx here will be, what's our v? Our v is 3x plus 2. No, let me just continue it here. So that's, yeah, let me just, please don't let us forget what we are doing. Don't let us forget the question. All right, so our dy dx now, our y prime, will be v. We've gotten v to be 3x plus 2 into du dx. Our du dx is 2. Then minus u. Our u here is 2x minus 1. 2x minus 1. Then our dv dx is 3. Then all over v squared. What's our v? Our v is 3x plus 2. So 3x plus 2 all squared. 3x plus 2 all squared. So the next thing to do is just to solve the equation. Just expand, do the necessary operation. All right, so we can just open the bracket by saying 3x times 2, that will be 6x, plus 2 times 2, that will be 4, minus into 3 times 2x is 6x, minus 3 times minus 1 is minus 3, then over 3x plus 2 all squared. So we can have it as 6x plus 4, right? Minus 6x, then plus 3. Because this minus, we have had this minus. So making it to be plus. Then over 3x plus 2 all squared. So from here, 6x and minus 6x we cancel out. So we only have 4 plus 3, which is 7 over then 3x plus 2 all squared. No need of expanding it. You can just write it like this. And even if you want to expand it, that will be 7 over 9x squared plus 12x plus 4. In case you want to expand it, that will be 7 over 9x squared plus 12x plus 4. All right, so now, but if you want to use the approach of product rule to solve it, there is a way of doing that too. There is a way of doing that. For instance, I will solve the questions related to that for us, that we can use quotient rule to solve. All right. That we can also use product rule to solve rather. Now let's look at this particular question. Let's look at this particular question. Okay. I believe we are all following me. Okay. Yeah, all right. So now looking at this kind of question, x plus 1 over x minus 1, and I want to use quotient rule. This is quotient rule question, right? But I want to use product rule to solve it. What I just have to do is I just have to do some manipulation using some indices approach and the likes. So for instance, I can write this particular question as x plus 1 into x minus 1 raised by minus 1 using law of indices, because this is as if you are saying x plus 1 then times 1 over x minus 1. We get it. And 1 over x minus 1 itself is x minus 1 raised by minus 1. All right, so using that scope now, differentiate the first one. If you differentiate this, it is 1 because derivative of x is 1. So keep the second one, meaning I will write this, right? Then plus keep the first one. Keeping the first one, that will be x plus 1. That will be x plus 1. All right. So differentiate the second one. But if you want to differentiate this, you have to be very careful. The derivative of this one means you differentiate what you have here. That's 1. You times it with the power minus 1. You rewrite the question x minus 1. Then remove 1 from the power. That will be minus 2. So you have to be very, very careful. You have to be very, very careful. All right. So now we can have x minus 1 raised to power minus 1 plus x plus 1 into bracket of minus into x minus 1 raised to power minus 2. X minus 1 raised to power minus 2. All right. Now this can also be written as I want to return it back to fractional form. I can write it as 1 over x minus 1 according to law of indices plus x plus 1 into bracket of this can be written as minus 1 over x minus 1 raised to power 2. So I'm just using indices approach. So this is where we are now. And if you like, you can still do some other thing. You can solve further. Can solve further if you like. Can solve further if you like. Coming. Can solve further if you like. All right. So from here now, from this particular one here, from this, our dy dx now can be 1 over x minus 1. Plus times minus, plus times this minus is already minus. So minus x plus 1 over x minus 1 all squared. All right. Okay. All right. So from there now, we can see our dy over dx now because the SAM here is x minus 1 all squared. So x minus 1 in x minus 1 all squared is still x minus 1. So we have x minus 1 minus into x plus 1. So and that will be x minus 1 minus x, then minus 1 because plus minus times plus will give you minus. Then over x minus 1 all squared. This we cancel this. So we are left with minus 1 minus 1, which is minus 2, over x minus 1 all squared. All right, so this is a way of using product rule to solve quotient rule question. All right, but it's kind of you have to be very, very smart when dealing with stuff like this. When dealing with stuff like this, you might not be able to use it for complex questions, but questions like this, you can make use of it. But I would advise anytime you have questions related to fraction or you have questions related to division, always apply quotient rule. It's very, very, very straightforward. Very, very straightforward. Very, very straightforward. If you know that your capacity in indices is not that very, very sharp, very, very high, I would advise you go for the direct method, which is the quotient rule method. All right, so let's look at another particular question that says that if you have y equals sine x plus cos x over sine x minus cos x. So how do we tackle this? We have to know what our U is, and we also need to know what our B is. Our U is the one on top, which is sine x plus cos x. So differentiating this now, du over dx will be differentiate sine x, that will be cos x minus differentiate cos x. Don't forget if you differentiate cos x, that's minus. That's why I've already written the minus. But let me just do the normal approach. That will be minus sine x, right? So we have cos x minus sine x as a derivative of u. Our b is the denominator, which is sine x minus cos x. Then from here, dv over dx will be equals to our sine x normally is cos x if we differentiate it minus cos derivative of cos x is minus sine x, right? So our dv dx can be written as cos x plus sine x. So following the approach, the formula for quotient rule that says v du dx minus u dv dx over v squared. So this is what I want to follow now to solve this particular question. Okay, so our dy dx, our dy dx here will be v. What's our v? V is sine x minus cos x. It's just be following me. It can be kind of messy in a way, but just follow me very closely. All right, so our v is sine x cos x. Why our du dx? This is our du dx. Let me just put it here. Let me put it here. Du dx is cos x minus sine x. Du dx is cos x minus sine x. Okay, okay. So okay, so minus our u is sine x plus cos x, and our dv dx is cos x plus sine x. Then everything over our v, right? So everything over our v, everything over our v. Coming. So sorry. Okay. So everything over our v. And what's our v? The v is sine x minus sine x minus cos x all squared. So if you like, you can try to open the brackets to make the work easier by saying all of these times all of these. So sine x times cos x is sine x cos x. Then sine x times this is minus sine x of sine squared x. I'm trying to open this particular bracket. I'm trying to open this particular bracket. Then I will also expand this. All right, so then minus cos x times this is minus cos square x minus cos square x. Then minus cos x times minus sine x will be plus sine x cos x. I'm done with the expansion of the first one. Minus the expansion of the second one. That will be sine x times cos x, which is sine x cos x. Then this will be plus sine squared x. We also have this to be plus cos square x. I have plus cos square x. And we also have cos x times sine x. That will be plus cos x sine x. Then everything over v squared, which is sine x minus cos x all squared. All squared. All right. So I believe we are still following me. I believe we are still following me. If we are still following me. If we are still following me. All right. So we can write this as dy dx equals from here. Sine x cos x plus sine x cos x will give us 2 sine x cos x minus. Now, if we bring out minus for this, we'll be left with sine x plus cos x. And what is sine x plus cos x? It is 1. Please always take note of that. What I'm trying to do is I'm trying to write this as minus is common, then we'll be left with what I'm trying to do here is I want to do something with this by saying that minus is common. I brought it out. So we'll be left with sine squared x plus cos squared x. And according to trig identity, one trig identity told us that our sine squared x plus cos squared x is equals to 1. Our sine squared x plus cos squared x is equals to 1. So meaning that this particular equation that I have here, I can represent it with 1. I believe you are all following me. So let me just erase this. Let me erase this. Then I will put 1. All right. So we are done with this first one. We are done with this first one. All right. So minus, let's move to the second one. Sine x cos x plus cos x sin x is still the same thing. It's just as if we are saying AB plus BA. AB plus BA is still the same thing as 2AB. You say 2ba. You will get it. So sin x cos x and cos x sin x, they are the same thing. So adding them together now will give you 2 cos x sin x. All right. Then plus, now the same thing that happened here can also happen here because this is sin square x plus cos square x. So sin square x plus cos square x automatically is 1 according to trig identity. Then over sin x minus cos x all squared. So if you like, you can expand this. Okay? You can expand this. But most cases, we don't expand the denominator. Most cases, we don't expand the denominator. Like I said, it actually depends on the options that you are given in your question, or it's actually depending on the final answers that the maybe the examiner on the marker needs from you. But generally, we don't expand this particular denominator here. We don't expand this particular denominator. We don't expand it. All right, so continue. Let's continue with what we are doing. So dy over dx now can be written as 2 sine x cos x minus 1. So let's use this minus to open this particular bracket. So that will be minus 2 cos x sine x. Then minus times plus will be minus 1 over sine x minus cos x all squared. Now, 2 sine x cos x is the same thing as 2 cos x sine x. It's just that the arrangement is kind of different, but it's still the same thing, meaning I can cut it out. Yeah, please always take note. 2 sine x cos x is equivalent to sine 2x. Take note of that. 2 sine x cos x is the same thing as sine 2x. That's the trig identity. All right, so 2 sine x cos x minus 2 cos x sine x has cancelled out. We are left with minus 2 because that's minus 1 minus 1 minus 2 over sine x minus cos x all squared. So this will be the answer to the particular questions that we are dealing with. This will be the answer to the particular questions that we have been dealing with. All right, so let me solve the last example for us on quotient rule. Now we'll call it I will call it a class, a wonderful class for us. All right. So do well to like the video, do well to comment, do well to subscribe, and do well to share with your friends. All right. So let me just solve the last example for us on quotient rule. And by God's grace, I will be dropping the next video very soon. So watch out. All right, so the next question is y equals e raised to power x over x. How do we solve this? This will be our u and this will be our v. So if u equals e raised to power x, right? And our du dx is we also be e raised by x. I've taught us that before. And we have v to be x, then definitely the v dx should be what? That should be 1. All right. So following the approach, dy dx, like we used to say, is equals to v du dx minus u dv dx, right? Over what? V squared. So meaning from here now my dy dx now should be equals to v. Our v is x. Our du dx is e raised by x minus our u is e raised to power x, and our dv dx is 1, right? Is 1. Then over v squared, which is what? Which is s squared. So um from this particular one now, yeah, from where we stopped here, from here now we can say that our dy dx equals x e raised to power x minus e raised by x, because e raised by x times 1 is e raised by x squared. But they have something in common. E raised by x is common. We can write it as x minus 1, then over x squared. So thank you so much for joining this class so far. Thank you for paying up attention. Do well to like this video and do well to subscribe. Do well to comment and do well to share with your friend. Thank you so much. God bless you. So we meet again next class. Thank you.